Once we have a couple of points on the curve, how is the robotaxi expansion going? Then you can extrapolate forward. We have to get past the beginning. We're at 30 cars or whatever in Austin right now, so it's a really small thing. So we're on the flat part before, we're just entering the exponential part. At a minimum, you have to get well into the exponential growth of the early phase before you can figure out what the exponent of growth is and make a prediction. I think you can't make it right now. But I don't see good reasons to doubt, essentially what Elon has said about this kind of stuff. Like there isn't anything I understand technically about this problem, and there's nothing in the data that I've studied that suggests like there's good reason to believe that he can't be right. Like he could entirely be right. And his track record recently has not been bad. That's the point at which regulators can't not approve it. Like if you've got an order of magnitude improvement, right? They can approve it. They can approve it anytime they want. If it's 10% better than humans, it's still a win. My guess is Tesla would like to be able to have data that shows a statistically significant, kind of irrefutable advantage before they want to go to regulators and argue that they can do that. And if Elon is saying he thinks FSD unsupervised is doable in 6 months, he's looking at that improvement curve and saying, in 6 months, it looks like if things go okay, we'll be in that zone where we could prove that it's that much better.
Today, we're joined by Tesla retail favorite and expert James Douma. Tesla's Robotaxi service has launched, but we'll ask him what happens next. How close is Tesla to true unsupervised autonomy? And when will Tesla's own supercomputer Dojo help? What truly separates Tesla from competitors like Waymo? And how exactly will Tesla scale? How many vehicles? Which cities? And what will be the roadblocks and hidden limits to scaling millions of robotaxis? If you're a Tesla investor, this is the conversation we've all been waiting for. Thank you, James. I appreciate for you joining me again on this channel.
Yeah, nice to see you again. It's been quite a while now.
Yeah, lots have happened. Actual things have happened. Robotaxi was launched on Sunday. You've had a chance to ride, a significant number. I think I read 25 rides at this by now, if not even more. You've got to really, think this through. First question is just, trying to understand when will Tesla's unsupervised, full self-driving, the technology, when is it actually going to be solved and really rolled out to the point that I think people are still confused. They don't know if it's hit the magical 10,000 miles per critical intervention or 770,000 miles per critical intervention, 10 or 20 times safer than a human. Do you have any confidence level of if that's going to happen and when that might happen?
Well, I don't think Tesla internally has a metric like that they're working against. They're probably looking at, how the Robotaxi experience is going to provide them with a lot of information about how the driver is working. It looks like the driver that they're using in the Robotaxi vehicles is virtually identical to the driver that they're using in the V13 vehicles that everybody has right now. If you use V13 much and you ride around in Robotaxis, you'll find that for the most part, the experience is really similar. I noticed the biggest difference is that it looks like they have polished up the parking lots quite a bit. Like parking lot behavior on V13 it's never been great. I mean, it can navigate parking lots, but it kind of it feels like V11 on parking lots. You get into a parking lot, it's a little bit jerky, it's more hesitant, it seems like overcautious around pedestrians. Parking lots are less constrained than the road. The road system there's always a thing you're supposed to do. And then, if there's an obstacle, you have a couple of good, alternatives, and they're typically pretty clear. In parking lots, it's much more of a free-for-all than that. And parking lots can really vary a lot. Like there's many different ways you could go about getting to where you want to go. Finding your way through a parking lot involves, a much more rich set of decisions and, things you have to deal with. And so you see the car kind of slow down and be jerky right now when you get to the end of your drive, you pull into Costco. And once you get into Costco, things kind of slow down. You do get where you're going, but it's not as confidence inspiring. Mm-hmm. And the Robotaxi is quite different in this response. It doesn't slow down at all. It's heading straight for where it wants to go. And a significant amount of this, it's not because the dynamics of the driver have gotten significantly better. The main thing that's going on here is that, Tesla has provided more constraints for what the inside the Austin metro where they're operating, right? They've constrained the thing. So it's got fewer choices. It moves more smoothly. And then they've added more data for parking lots. They've probably done more training on parking lots. But so the net result of that is that the Robotaxi experience is just completely smooth from end to end. You get in, it pulls away from the curb with authority. It moves at the right speed when it's going through parking lots. It's not oversensitive to pedestrians. It's never risky with pedestrians, but it just feels like it's doing the right thing pretty much all the time. It's a very good experience. I have used Waymo a lot in San Francisco, which I think is probably one of the best cities that in terms of performance for Waymo right now. And the Robotaxi, it's not inferior to Waymo in any way, as far as I can tell. Like as far as the user experience of like sitting in the back seat, riding around, doing something, I would say it's better. The experience I had in Austin is better than the median experience I have in San Francisco. Those are very different environments. I didn't try riding Waymo. I wanted to get as many miles as I could on Robotaxi. So I just used it all day, all the days I was there. Whenever I could get free, I went. And I ended up doing like 43 rides. But I did a lot of really long rides. Like a lot of my rides were 15, 18 minutes long. Yeah. So I tried to, explore as much of the metro area as I could. I tried to go to as many different, pickup and drop off locations. And I got to see all kinds of crazy stuff. Like the first day that I was there, I got to see that, my route went right through a traffic accident, And then on the way back from that, there was like an emergency services vehicle taking care of, like, it looked like, somebody was having a medical emergency in a bar or something like that. And so there were all these cars in the street. So watching the Robotaxi, approach it, slow down and pull over, wait to make sure that there were no first responders, and then move into the oncoming lane. It's at night and there's lots of space, but and then give the whole zone with the emergency vehicles plenty of space. It moved around it, and then it just continued the drive, right? You don't get the impression like it was stuck. You don't get like one of the things that happens, Waymo in San Francisco is very timid. A lot. Yeah. Yeah. Well, I don't know. The internet can magnify the failures. I don't know, maybe last year I did 100 Waymo rides or something like that, just in my normal daily life. And Waymo is a very good service. Like I definitely recommend it. Like if we can use a Waymo, we do use a Waymo when we're in San Francisco. It's a great service. It's a year ago, it was pretty robotic. It felt very FSD V11-y in the way that it behaved. It's much smoother now than it used to be. It's a lot more aggressive. Like a year ago, they were getting stuck in situations that a human wouldn't get stuck in because the car was still fairly timid. And so it's still timid in some interesting ways. It's very careful around pedestrians. Like if pedestrians get too close to a Waymo, it just doesn't move. It just sits still, which occasionally you get these interesting things where, you'll see a first responder who's trying to get the car to move or something like that, or some construction worker who's trying to give it. And he's standing too close to the car and the car's frozen in place and he can't figure out why it's not, because a human would move. And I've seen the Tesla Robotaxi in exactly the same situation. And it doesn't have that hypersensitivity to proximity of pedestrians. So I was delighted to see how well it worked. And V13 is generally good in construction. I started from Los Angeles, and I have a Cybertruck, which I use to drive to Austin. So I was on FSD for like 26 hours going to Austin, right? Mm-hmm. And I got to see all of the wonky stuff that you see and stop at all the, chargers along the way and whatnot. And then I rode the Robotaxi around for 5 days. And then I had the truck drive me all the way back. So it was plenty of time to think about what's going on with the environment. But I was super happy with it. The quality is really good. The area they started with is, it's smaller than San Francisco. I think it's probably on the order of 20 square miles. San Francisco is about 50 square miles. The San Francisco Waymo area might be a little larger than that. The Waymo area in Austin is bigger than the Tesla Robotaxi. So that felt a little bit constrained, but it didn't feel like it was just a demo, though. It definitely did not have demo vibes to it. It felt like a real service. The app was polished. All of the little weird things that happen, like they had thought them through, and there were good ways of handling them. Like the whole What do you do if somebody opens the door while you're driving? This Emmett Peppers ended up inadvertently testing that, and support immediately comes on to ask what the problem is or whatever. If you forget something in the vehicle, like they've already figured out how they're going to handle that, how they report those kinds of things. It's, it feels like a service. I think it started, I expect them to expand the area when they're comfortable with expanding the area. I imagine the first thing they'll do is they're in South Austin right now, which is basically, if you know Austin, it's got it has a big highway to the west, which is Mopac. It's the one. And then it has a big highway on the east side, which is the 183. And then it has the highway, Interstate 35 goes right down the middle. So basically everything between those two that's north of the 71 and south of the river, that's South Austin. And so they covered that whole area inside that boundary. So North Austin is a mirror image of that, but it's north of the river and roughly doubles the area. So currently Waymo does the South Austin part, and they also do the North Austin part, but that's the limit of what they have in their service area. So my guess is that the next expansion would naturally be, North Austin. Yeah. And in the last couple of days, we're seeing signs that they're doing. Yeah. And so I will be super happy to see them expand to North Austin. Like if they do it in the next month, I think that's very impressive.
What's your confidence level of them? So you don't think that they have the metrics of 10,000 per critical, but when are they now going to be ready to feel confident that it's going to be able to do multiple cities and so forth? And then on the related question is, Farzad asked Elon recently, just a couple of days ago, he said, it's when do you get to remote operator to cars to be more than just 3-to-1, 2-to-1, or 3-to-1? You have like one remote operator for every 3 cars. And Elon said maybe in 2 to 3 months. I'm not sure if he's exactly referring to that or if he's just referring to the idea of a remote operator. What is your sense that they're operating right now, and when does it get to the point where they can get to 10-to-1 or even 100-to-1?
I don't. I get a remote operator intervention on Waymo maybe once every 20 rides or something like that. I would, just roughly speaking. You can tell because they tell you when there's a little message on the board that pops up, and you can tell that the car decides to stop and it'll be stuck for a while, sometimes for a long while before a remote operator comes on. If Waymo has 1 to 3, like that hasn't, I'd be surprised if the ratio is that high, if they have 1 remote operator per 3, because it takes 5 minutes for a remote operator to get to you, and you get stuck in a Waymo right now in San Francisco, and they only, they're done with you in 30 seconds or something like that. So that doesn't seem, and then considering the number of interventions they have, that's a lot. I didn't see any operator interventions when I was using the Robotaxi service. In YouTube videos, I saw that Dave Lee with his wife, they experienced an operator intervention. But that's the only one I've even seen.
UPS truck. Yeah.
No, not the UPS truck. When he's with his wife, the navigator for the car tried to turn left out of a parking lot, except it was turning left onto a busy street, and it was the corner. It was the corner driveway, very close to the corner. So the problem that the car had, and you watch through a couple of cycles of the light, is that you can't turn out while the traffic is flowing, and when the traffic stops, it's backed up and blocking you. Yeah, so it went through a couple of cycles. You just can't turn left there, right? Dave said in the video, like normally you wouldn't. In the middle of the night, you might turn left there, but in the day when there's any traffic, you wouldn't. And he says in the video, I would turn right here and go around the block or do a U-turn or something like that. And so what you saw is you see an operator intervention where, it sits through a couple of cycles of the light. And remember, the safety monitor can't drive the car. All they can do is stop the car, which isn't useful in this situation. So what happened is the car noticed that it had been sitting still for a while. An operator came on, canceled the route, put a new drop pin just to the right. So then the car came out and it turned right. And then after it set that pin, they reset the route to the original route. So then the car went around the block and it completed the route. So the operator doesn't come on and drive the car. the operator canceled the route and said, hey, it looks like the solution to this is to turn right here. So it just temporarily set a pin around the corner and to the right, so that the car would exit and turn right. And then it reset the route to have the same original destination. So then the navigation system, it figures I'm going right on this road right now, and it calculates a new route and it completes it. So that's how it gets fixed. But so that's, in all the videos I've seen and in all of my own experience, like I've probably looked at, I don't know, hours and hours of rides at this point. And that was like 5 seconds of operator intervention. So what are these operators doing if there's one for 3 cars, right? For the most part, they don't have to detect an event. The vehicle detects the event and notifies them. So I'm not sure what that comment was about.
I see.
I imagine the back office has a lot of people who are monitoring the fleet, who are involved in, seeing what's going on, maybe adapting to construction, adapting to weather. And at the state that Tesla's in right now, they're gathering lots of data. They're learning rapidly about how to operate the system, what works well, what doesn't work well. I saw one of the people in the back office was talking about how they are adjusting the algorithm to reduce wait
orchestration. Time. Orchestration, right?
So, and that's going to be a moving target, because how you orchestrate like 30 vehicles in South Austin is very different than when you have 500 vehicles in South Austin, right? In a lot of ways, it's simpler if you have more vehicles. The heuristic for how you distribute them is not as complicated. Well, if you've got few vehicles and few riders, right, it's you want to move the vehicles where the riders are, but you've got a relatively few places where all the riders are. So all the vehicles, like if they're idle, they're going to head to where they're most likely to get a ride, so that they're close by, right? But then if you're at the end of town, and right now they've got this weird thing where there are all these people who are they're testing the system and they're taking all these really long rides. So they're driving all the way out to the edge of the boundary, and so you're way out there and you're calling one, and the car it's moved back over to South Congress, which is probably where most of the activity is. And now you have to wait 8 minutes for the car to get to you, because, so they can tweak that algorithm and make it better. But anyway, this is all just growing pains. All this stuff is super easy to fix. Like none of this is important.
It sounded to me, James, that in your mind, what I've heard you say so far, reliability FSD is not the concern.
No,
I don't know. I don't want to put words in your mouth, but it's like it's operations, it's scaling, but you feel very confident at this point, especially that you've experienced Waymo do this, and so you don't think that Teslas necessarily have any roadblocks for, some people something they have to hit the March of Nines. Where are we with the March of Nines?
I don't feel like the failures right now, they're not going to be. The scary failures that people have in mind is the car does something stupid and it results in an accident and somebody gets hurt.
Right.
That's going to be vanishingly rare, even on the current thing. Like I have way over 10,000 miles on V13 at this point. I've never had critical intervention, right? So I almost never have interventions. Like occasionally I'll want to go a different way, so I'll intervene, right? Or I'll get to the end. I won't have the patience to let it navigate through the parking lot, so I intervene. But my interventions, they're all navigation stuff, right? Interventions I have where like I'm doing it because I'm averting an impending collision. Like I haven't seen one of those on V13. I don't, in a year of driving on V12, which was, that was kind of a slow year because we weren't doing as much, but still like maybe 20,000 miles on V12. Maybe I had one. I don't know.
Yeah.
So
I've been telling people that I have a hardware 4 Model 3, and it's now been 4.5 months. Every single day I drive, I have not had a critical disengagement for 4.5 months, and I've taken it to Portland. I've taken it to Seattle. I'm sorry, I live in Seattle. I've taken it to Vancouver, Canada. And then just this weekend, we went to a resort in Western, and all the rides, everywhere, wherever it goes, everywhere in those places. No disengagements for 4.5 months. But then I say to myself, hey, I'm an N of 1, not yet 10,000. There's a magical number of 700,000 that Tesla apparently has to hit within March of Nines before that they can truly go city by city by city. But and so the expectation with the growth of the compute,
Mhm.
We've not seen, so we've seen the version I have in my car today is not what they're using in Robotaxi today. And then there's another one that's a 4 times parameter that's supposed to come sometime, some second half of this year, according to Elon. What are we expecting with the power, the reliability improvement of each of these?
Yeah. Like, I don't think even Tesla knows this. So anything you say
I
on it
see.
is going to be a speculation. Last year, when V13 first came out, the initial notes said, soon we're going to get a 3 to 5x parameter increase. And as far as I can tell, that never happened. It never came out of the notes. It still says, soon we're going to get this, or maybe they got rid of that note or something. But we never got a version that said, hey, this is the new version that has 3 times
Yes,
as many parameters.
correct.
And I'd be willing to bet for 2 reasons that they never pushed a higher parameter one. The first is it takes a long time to download these models. Like, if I look at how long they take to download, like when V13 came out, because it's a lot bigger than V12, the download times,
Over an
they
hour.
massively expanded, right?
Mhm.
And those are the parameters dominate the download size. So, if the parameters, if there's 3 times as many parameters, 5 times, the download is going to get 3 or 5 times longer. Like, we're going to notice that when it happens. We're going to see it in the download speeds. That's one thing. The other thing is that there's no point in doing the 3. If they do a new model that's 3 or 5 times, you're going to see a step change in behavior. And now it's not going to be a radical increase in the features because it's basically feature complete. There really aren't things it can't do right now that it needs to do. I mean, the Robotaxi basically demonstrates it can do the whole stack of everything it needs to. What you do see is it gets smoother and more confident. There's less hesitation. It's never too fast. It's not too slow. It's just doing the right thing at all times. And there wasn't any point in all of the V13 update, because I think I must have got 20 V13 updates. And there was never an update where it suddenly got significantly smoother or there was a significant change. They were almost all, minor bug fixes that it would say. So I think that when they first rolled V13 out, they had a plan to do a bigger version of the model. But, what goes into training a bigger version of the model? You make the bigger version, you have to quantize it, you have to do the distillation, you have to quantize it down to make it fit, you have to do tons and tons of optimization to get it to run inside the thing. And you're only going to do that if the net result is better than tweaking the model that you currently have. And I think what they found after they got the first version out is they kept tweaking it and it kept getting better and better and better. So there wasn't really a point where they felt like they had plateaued and they needed to go to a bigger model. It just kept improving. So the plan changed. Originally, they had thought, we're going to plateau in 3 months or whatever, and we're going to go to this bigger model. And they had that on the back burner, and they just didn't need to. And so we never got the 3x bigger model, not because they couldn't deliver it, but because they didn't need to. Like, the driver for doing it didn't appear. So now they know that they can do a bigger model, and bigger models will perform better, right? Bigger models get you certain things. So if they can put a 4.5x bigger model in the hardware, at some point it makes sense to do that. You've got the hardware there. You might as well use it. Get as much accuracy as you can out of the thing. So why? So why is it 4.5 instead of 3 to 5 before? They've probably done more of the back end optimization now. So in the beginning, when they originally were saying 3 to 5, they had this kind of idea of like, well, we're going to do these set of optimizations, and that'll give us this much more capacity. Between 3 and 5. So it was kind of like not well characterized because they hadn't figured out all the well, so now they're saying like 4.5, which is a much more definite number. And I would say like that sort of illustrates that they've done a lot of that back end work now, so they can run the bigger model. They haven't built a bigger model. They haven't deployed it. They haven't tuned it and done all of that kind of stuff, because they've been able to get to like where they can start rolling the Robotaxi service, and they haven't even had to go to the bigger model yet. So, that's just been on the back burner because they want to move as fast as they can. And if you can get there without having to stop everything and go to a new model, like, that's a win, right? Which is not to say that you don't eventually put the bigger model in there. At some point, you do plateau, and that becomes the low-hanging fruit. And so you do that thing. But the fact that they didn't do it, I feel like, is actually a testament to how powerful this technique is. Like, they've been able to get the performance improvements that they wanted without having to make the model a lot bigger. And, that speaks well of like what the platform is capable of, because they've still got that extra 4x that they can do. Like, whenever they decide that they're stuck, they can go do that thing, and they're definitely going to get a performance improvement.
This is unbelievable what you're saying right now. So I must separate two things, right? There's Robotaxi rollout, which your analysis of how the business model there, it blew me away last year when you started talking about it. I want to get you back on that. But there's two parts, right? There's Robotaxi rollout, but there's also this idea that our own cars, number one, can get out of the factory and drive to the customer's home, certainly in Austin first. But there's this thing that Elon's been saying that at some point he thinks that in my car here in Seattle, will be able to sleep and they will pay for, I guess, the legal liabilities.
Yeah.
Do you think that the existing model that I have now, the FSD version, that's going to be able to do that? Or do they need to wait until the 4.5 times model for that?
If the current model could do it, they'd turn it on, right?
Okay.
So, the current model, they haven't turned it on, so they don't feel like it can do it. So on the other hand, what improvements do they feel they need to do before you get there? And how are they going to do those improvements, right? So maybe it's the 4.5x model. Maybe that's the one where, sitting in there, they're looking at how things improve, as they iterate, as they get more experience, as they tune. There's a lot of stuff besides just changing the model, that goes into this stuff. There's lots of small changes that they can make to the models that don't involve retraining a new model, that can lead to performance improvements where they're wringing more and more performance out of the model they have because they're learning how to better use it to do the driving problem. So are they internally looking at what they're doing on these other things and feeling like that's going to get them there? I mean, the last thing Elon said about timing for unsupervised FSD, I think he said that this year was what he was expecting, right? So inside 6 months. Will we get that? Is that Elon's time?
Right.
That's an interesting question. Do I think it's implausible? Do I think it's not possible to do it? I do not believe it is not possible to do that.
Wow.
Okay. So what would you expect that service to look like when it rolls out? So one of the things that we're seeing with Austin, right? The fundamental architecture of the system, it's not designed to be a geofenced system. It's not a system where we go into an area and we learn everything about a particular area, and that's critical input to the model that it needs to have in order to be reliable. It is the kind of thing. And I think what we're seeing in Austin with, they have these, high top scanners that looks like it's a camera array that looks down. So they're driving around, adding bird's eye data captured from the cars. Why are they doing that? I don't know. Maybe they're geolocating the roads more accurately because they want, better GPS positioning accuracy for now while they're operating. Maybe it's got something to do with why the parking lots work better. We might see all that stuff. Yeah. So I saw these vehicles when I was in Austin, but I only saw them at a distance. And the first thing I thought is, it looks like one of those LiDAR buckets, like the Waymo have on top of them. Yeah, it doesn't seem to be that though. I took a couple of still frames, from the best images that I could make. And the top of that thing is an octagon. So it's not round. It's not a spinning. First of all, it doesn't spin. It's not a cylinder. It's kind of like a kind of inverted octagonal cross section cone, slightly tilted down. And it seems like it has a camera lens in the middle of each one of those facets. So it's 4 cameras or 8 cameras, sort of getting a look around the car as it drives. Are they looking for potholes? Maybe they are trying to be extra careful about construction. So like every day they drive those through all the construction areas to see if anything important is. Like, is there a big trench the car could fall in that wasn't there yesterday? Ultimately, the idea is that the Robotaxis don't need any of that stuff, right? But, they're belt and suspenders right now. They've got a lot of attention. They want to be super careful when they do their intro. And of course, there's uncertainty anytime you try to do something new. So ultimately, they don't need that stuff. But, I would guess that when FSD unsupervised comes out, that it will similarly be geofenced. Like they will know that, in rural East Texas small towns, that it's maybe not trustworthy, or it's not as good as it is in Seattle, in San Francisco, in places where they have lots of data and they have lots of experience. So I wouldn't be surprised if, when we get the initial versions of unsupervised, that the unsupervised version is geofenced, right? That seems totally plausible to me that they might do that, but that's not that's not a limitation of the architecture. It's kind of a maturity stage that they're going through on their way to, to being able to operate unsupervised basically everywhere. But car accidents are the cost of getting it wrong, and we don't want those. So they're going to be careful about it. Anyway, do I think it could happen in 6 months? I totally think it could. I would kind of expect it to be geofenced, but I wouldn't expect it to be geofenced to 6 blocks around downtown LA or something like that. I would expect, they would do all of the SF Bay area, say, as a geofence or something like that.
Is incredible. This is amazing. Okay, I was going to ask you about Dojo, but just quickly, I guess it sounds like Dojo is not required for this to reach unsupervised or expansion of Robotaxi. But what happens when that does come, like next year, 2 years from now?
Yeah. So Dojo isn't like some magic thing that lets them do something that they can't do with NVIDIA clusters, right? Yeah. Compute is fungible. The difference is how much does it cost to run a computation? Yeah. How long does it take to do the computation? Yeah. So Dojo at the 10,000 foot level, it does exactly what an NVIDIA cluster does. It produces exactly the same output. Ideally, it does it, in what is from Tesla's perspective, a more cost-effective way, something that's more scalable. NVIDIA, famously, they're super supply constrained. They're running behind on their roadmap for when they introduce new stuff. They're unbelievably expensive right now. So the cost of, it's funny that we talk about the energy that like an NVIDIA GPU uses, because if you buy one of these, if you buy a H100 or B200 and you run it flat out for its entire lifetime, the energy is only like 5% of the cost of operating the thing, right? Energy is very small because the systems are so expensive. And a big part of the reason they're so expensive is they're in such high demand that NVIDIA can charge essentially whatever they want. They have huge gross margins. So Tesla's paying these gross margins right now. If Tesla could build their own systems, first of all, they could have as many GPUs as they want, because the limit is how many die can TSMC make for you? It's not how many of, NVIDIA's allocation that they're willing to give to you. And then the other thing is they don't have to pay the NVIDIA tax, right? The systems all instantly get 5 times cheaper, right? So the promise of Dojo is that as they scale, imagine they're spending, what is it? XAI is going to spend like $10 billion on NVIDIA clusters, essentially. So for the same price, they could have 5 times as much Dojo, right? So the Dojo is a radically different architecture. Like a thing about in Dojo versus NVIDIA. NVIDIA GPUs, or GPUs in general, are not the reason that we use them to do deep learning computations to train neural network models is not because they're the ideal architecture for it. When neural networks started getting trained, there was no good computer for doing it. The GPU was the least bad of the bad options that were out there. You really need something that's different, that's designed to operate on big matrices. GPUs have a lot of small processors in, each one of those cores, they have hundreds of cores or something like that. But neural network training, there are nice aspects of having lots of relatively little processors. But Google's TPUs are much more efficient. They're designed to do neural networks, and they have giant honking multipliers in there. In fact, they use an architectural technology called a systolic array, which is much more energy efficient, much better suited to most of the computations that go in. And so they're a big win if you do that. Now, systolic arrays, they have certain limitations. There's a few things that you do when you train neural networks that they're not very good at. And so they're kind of slow on that part of the thing, but they're really fast and really energy efficient on the most important parts of the thing. Dojo is kind of a compromise between those two. It still has relatively big multipliers. It has kind of configurably large multipliers, but it's not constrained to only operate in a systolic mode. It can, but it doesn't. So anyway, it's a clean sheet rethink of how you do the computational logic that goes behind neural networks. And I think it's a clever idea. that is probably architecturally better than GPUs for doing this kind of stuff. Now, they have a disadvantage, which is running these parallel neural network training runs on really big clusters is a very complicated software task. Like, in principle, it looks pretty simple, but in order to make good use of this $1 billion machine that you bought, you put all kinds of effort into reliability and redundancy and scheduling and making sure you can use the whole, because it's never like the whole thing running one job. You've got this 100,000 GPU cluster, and you're doing 200 different things on it. They're all different size jobs. And so, like, how do I map these different jobs onto this cluster so they don't interfere with one another and they're scheduled with storage and networking and all that kind of stuff? It's all very complicated, right? Yeah. Okay. NVIDIA did all that stuff, right? So you buy an NVIDIA cluster and that software already exists. But if you design a new machine, you have to do all that. So, that's what Tesla has to do. I think they're able to use Dojo for a set of constrained tasks they have, which dominate their which they spend a lot of compute on. Like, I think they're probably using Dojo for the auto labeler right now. That it seemed like that was the direction that it was going in, and one of the things that they were optimizing for. And so, they still do lots of auto labeling. Auto labeling used to be 40% of the total compute they did. So if they figured out how to just get the auto labeler running on Dojo, that makes it really useful to them. And it gives them a reason to build the systems, to test them, to stress test them, to understand the architecture, to figure out what they want to iterate for the next version, to keep developing it. And it must be doing something for them, because they've got like 10, right? And each one of those is an exaflop. Like, that's no small amount of compute. But the flip side, we don't hear a lot about Dojo, because
we're starting to hear more. You can hear Elon saying that it's looking like it's headed in the right direction.
But think about how big a project it is and how many people are working on it. But it's like Optimus. For given the amount of work that must be going on, we hear very little about it. And I think, especially with Dojo, they want a good relationship with NVIDIA. Right?
Yeah. They want to keep that. Okay. So this is great. This is what the first half of this, you've taught me that we dispelled a lot of the myths that a lot of people have had, including myself, which is FSD's march of, we'll get to true unsupervised, a march of nines when you've got compute growth. And that's what, if you follow compute, then you're feeling more confident that they'll eventually get to that point.
Also, I think it's quite good right now. I understand that it's very easy to go on YouTube and find somebody who videotapes something that looks kind of scary. But I think the reality of 13 is it's doing extremely well. I don't think it needs to get 100x better in order to be Robotaxi viable. I don't think it really needs to get any better.
I thought the measure was safer than a human. It's got to be 10 times safer than a human, or 20 times safer than a human. That's when regulators will approve it. That's what Elon said many years ago. So I don't,
that's the point at which regulators can't not approve it. Like, if you've got an order of magnitude improvement, right? They can approve it. They can approve it anytime they want. If it's arguably, if it's 10% better than humans, it's still a win. My guess is Tesla would like to be able to have data that shows a statistically significant, kind of irrefutable advantage before they want to go to regulators and argue that they can do that. And if Elon is saying he thinks FSD unsupervised is doable in 6 months, he's looking at that improvement curve and saying, in 6 months, it looks like if things go okay, we'll be in that zone where we could prove that it's that much better than they. And now, how they get there, there's multiple possibilities, right?
It doesn't have to be necessarily just wait for the Colossus or Cortex to grow. So let's get to the business model, because you have had some very good kind of putting things in perspective. One thing you said a long time ago was that a city of Chicago, for example, would has, I think, 10,000 Uber drivers. Not every one of them is available, but that's a driver model of rideshare. To own that market, it's really just 10,000. What's the point? That's like, gosh, Tesla can do that in like less than a few days of production, because every car they make is Robotaxi ready. And so how do you see this? What will Tesla do in Austin before they expand? So if clearly they have this one geofenced area, they're going to copy, match what Waymo's doing. they'll have 10 cars, 20 cars, 50 cars, 100 cars. Do you think that they'll do 2,000 cars, 5,000 cars, 10,000 cars in Austin? Or do you think they'll do 1,000 here, 1,000 there? I mean, honestly, Waymo has 100 cars in Austin. They have 700 cars in San Francisco, and they have like 200 here, 300 there. Like, it's tiny little numbers, honestly.
Mhm.
How do you see this rolling out for Tesla?
Uh, so Tesla's current limitation is they're learning the back operations and they're scaling up back operations to understand. And you had pointed out their back office operations are probably more manpower intensive relative to fleet size than they expect to be. As their back office stuff scales up and matures. So I think that's a limiter, right? Waymo's limiter is how many vehicles can you get, right? Waymo has a hard limit on this. The current Waymo, the Gen 6 vehicle isn't out yet. The I-Pace, the Jaguar I-Pace, that's our Gen 5 vehicle. They originally had a contract with Jaguar to buy 60,000 of those, which it made a lot of news like back in the day. They didn't end up buying 60,000 because they didn't scale up as fast as they thought. When Jaguar discontinued the I-Pace and then Waymo bought the rest of the inventory, which they've got parked in a field, and they're gradually converting them into Texas. They've set up a facility just for doing this, and they convert them at some rate, but they're going to run out of those. And the numbers that they talk about is like having 3,000, 5,000 by a year from now or 2 years from now. That's not a spectacular growth rate. And they do have to get into more municipalities. I think if they had twice as many cars in San Francisco, they could keep twice as many busy. The service is very popular, and it looks like they've taken about 30% of market share, but that they keep the vehicles busy. Like, they're very popular relative to Uber and Lyft inside for the set of rides they can do. You have to start and end in their service area. And so that's like, so any ride that starts and ends in San Francisco, you can use Waymo for. But if you want to go to Oakland, if you want to go to Daly City, if you want to go down the peninsula, like, you can't use Waymo for that because it doesn't end in their service area. But if you just consider the subset of rides that's in San Francisco, they've managed to take like 30% of market share in like a year. And I think they're probably vehicle limited. If they had twice as many, they could use them. They don't have the cars, and that's why they're not fielding the cars. So Waymo's limitation right now is like literally getting more cars for the urban areas that they currently serve, which is, San Francisco, Los Angeles, primarily. The Phoenix metro area, I guess they're growing that. Tesla's current limitation, and they just started last week, they're still at the 30. So this is not what they're doing right now is not representative of like their actual limitations, what the service actually looks like. Tesla's got to get the back office stuff, the operations kind of sorted out, working, develop confidence with the cars, and gradually expand the operating domain for the things within whatever set of constraints they feel satisfies their safety requirements. But they're not going to run out of cars. Relative to Waymo, Tesla's got infinite cars, and it doesn't take very many cars to satisfy the US. That 10,000 figure for Chicago, that's not the number of rideshare drivers there are. I took the rideshare data. In Chicago is one of the municipalities in the US that requires rideshare companies to log all of their data to a database that they can share, and it's public. So I pulled that data to calculate, I basically built a model to calculate, like, how many vehicles do you need to satisfy Chicago's demand? Turned out to be 10,005. So I rounded it off to 10,000. But basically, and the size fleet you need is how many cars do you need to satisfy existing demand at the busiest time that the fleet most of the time, most of the cars are idle. Because the busy time is much busier. It's kind of like the road system, right? The road systems, they don't stay busy 24 hours a day because people don't use them. They're totally jammed twice a day during rush hour. And then there's nobody on the road in the middle of the night. And the taxis have a similar kind of thing. So if you back those numbers out and then extrapolate them to the rest of the country, what you find is that to satisfy the existing demand, which is the existing demand is it's like $2.50 a mile is the average rate that people pay for rideshare service in urban areas. Urban areas are 80% of population. They're more than 80% of the rideshare potential. So they're the lion's share of it. a million vehicles satisfies existing rideshare demand, which is essentially all nationwide in the United States. So a million vehicles satisfies all of the existing rideshare demand, which is which is how many rides will people buy at $2.50 a mile.
250. Yeah.
As you bring that price down, the number of rides will expand, right? So probably, just ballpark, you could easily field 3 million vehicles in the US at approximately the same price. Maybe you're at $2, maybe you're $1.80 or something like that. But you can put 3 million vehicles out there. So who can put 3 million vehicles on the street in the next 5 years, right?
Yeah.
Like Tesla has real potential to do that. Tesla could put 3 million vehicles on the road in the United States, and it wouldn't be a stretch. And it is, as far as I can tell, completely impossible for any other player to do that. So you get to this point where everybody is fleet constrained because they don't have enough vehicles that will run their software and provide service for them. And Tesla is the least constrained. And incidentally, when I extrapolate that out, like how big can it get over time, the lower bound of what it looks to me like, right, like this service in the United States could be within the constraints of what we currently know about what it costs to provide the service is about 25 million vehicles. So until you get to like 25 million vehicles operating, like as long as people are willing to meet whatever the prevailing price is, or they have a differentiated service, there's really not, in a lot of ways, there's not really head-to-head competition. It doesn't become zero sum until you hit the limits and the margins go down to 10%, right?
Wow, so those are great numbers. And so do you think that, I guess we have to talk about this. I don't want to, but we have to. People talk about Waymo. They're the leaders right now. They have LiDAR. Can you address that? And then Uber's going to win because in 3 months, everybody's going to have a Robotaxi service. This is a software that is easily copy. You can copy it, and then everybody will have it. And then therefore you need an Uber to be able to, whichever automaker has autonomy.
I got asked this question recently, and the framing I came up with is like, okay, we know what Waymo uses, and that's what Zoox is going to use. That's what they're training for. The sensor, there's the sensor heavy approach where you got tons of sensors, you put lidars on, all that kind of stuff. Your car costs $200,000, and that sets the floor on like what you can drive your costs down. It also limits the number of vehicles you can have in your fleet because of capital constraints and how fast you can produce those complicated vehicles. It becomes an operational constraint. LiDAR it's very maintenance heavy. It's unreliable. The LiDARs probably don't last 100,000 miles, so you have to replace them. So that increases your operational cost. So that's one approach. We know what that looks like, and it doesn't scale very well. At least it doesn't scale today. And, that's what we know about it, right? Okay, lots of other people are going to come out of the woodwork and have an equivalent system to Tesla. Okay, what technology are they using, right? Because if they're using neural networks, they need a giant cluster, and they need an AI team, and they need a huge fleet to gather data. And none of the competitors, as far as I can tell, have a cluster or a big AI team or a large fleet. And the fleet is a critical thing. The Tesla's fleet doesn't just gather Robotaxi data. It actually gathers a much more important kind of data than that. The planner, we've talked a couple of times in the past about how, there's kind of 3 general blocks to what what's implemented in the Robotaxi software. One of them is perception, which is understanding the environment. One of them is planning, which is given my goal and the current situation, what should I do? And then there's control, which is once you've decided what to do, how do you get the car to do that? Right? Like what are the control things? Tesla's currently running an end-to-end stack. So they actually go from one end to the other. So it's unified, but they had a perception stack that worked pretty well. The main thing that they're getting with end-to-end now is they're getting a planning, end-to-end is really improved the planning system, which is the car basically deciding what it's going to do in the next instant is so much better now that they're end-to-end than it was before. And they get that benefit because they have a huge amount of human data that they train the car to mimic. So the planner mimics people. In order to mimic people, you need an enormous database of people driving in every conceivable situation, in the rain, through accidents, around construction, all of that kind of stuff. You just need mobs and mobs and mobs of data, right? And there's literally not enough. Tesla's got 7 million vehicles on the road that can gather this data, that do gather this data. Like when you drive your Tesla around, Tesla gets to use that data to train, the path planner that they've got. And there is no other fleet in the world. And if a large manufacturer set out today to build that fleet, it would be 5 years before they had it. So how, like, what magic technology is going to be used to make this thing? We only know two ways to solve this. And one is the way Tesla's doing it, which nobody else can do right now because they don't have the infrastructure. It's not that the technology isn't available. It is. You could get copies of Tesla's driver. It doesn't help you, right? Unless you're driving a Tesla vehicle. You need that fleet in order to be able to do this development. And nobody else has the fleet, and nobody has the fleet. Nobody's building the fleet, right? And it takes 5 years just to plan out the design of a vehicle that you're going to do. And then you have to build cars for years and years. You have to build really popular cars for years. And then your customers have to drive them for years for you to have the database to do this stuff. So no, there's nobody else that's going to have this.
I'm sorry I made you have to say all this over again. Thank you. Yeah. I appreciate you confirming that. I mean, I did hear somebody say recently that, okay, this is the right approach. Tesla's shown it. But the world has changed in just the last 6 months, a year. You have faster compute than Tesla had years ago. You already understand how the neural nets work and LLM modeling it, copy the way that they did it.
Technology is getting better and better. And
so the amount of data, it won't take them as fast as long as it took Tesla to get to where we're at. Those are all true things.
But it's not like it goes from, I mean, you look at it's not like it goes from, I need 1 million vehicles to I need 1,000 vehicles, right? With an incremental change in the thing. The technology, the data efficiency of the system has to get radically better. And we see Tesla is at the threshold of being able to do it right now. That is, it's not like Tesla has 100 times more compute or 100 times more data to do it. They're just now getting to the point where they've got enough data to get a reasonable system, right? So we can look at like what they have today as kind of a thresholding thing. Anybody that's significantly underneath that, like if you have half the data, if you have 1/10 of the data, you need a radically better technology to be able to do the same thing with 10 times less data. But nobody has even 1,000th of the data. Right? I mean, there's no, it's not to say, there could be some crazy breakthrough tomorrow. There's nothing on the horizon nobody in the field expects some massive breakthrough that basically breaks the current scaling curves. Like scaling laws for the kinds of models we build today, they're very well understood. They've held for many orders of magnitude of increase, and people basically expect those to continue going. Nobody expects, if for that curve is going to change radically for existing techniques. Are there other techniques? There could be. I read all the papers. I haven't seen one. And
somebody says AGI. When AGI happens, they can learn how to drive. They don't need all that.
Yeah, it's true. But you'll need. You're going to need a cluster in your trunk to run the kinds of algorithms that AGI does right now for doing that kind of stuff. I mean, AGI is going to be useful for helping us come up with better ways to make the thing that goes in the car. We won't be using it to drive the cars, at least not anytime soon, because of
well, I mean, if it happens, it'll probably 3 to 5 years from now. And if it's 3 to 5 years, where's Tesla with all their cars? And that's already out there doing the system. What's your guess of how many cars Tesla will have in the Robotaxi network by the end of this year? Are you thinking 1,000, 2,000, maybe even more?
Elon likes to say, when analysts ask him, at what point is your production ramp going to be complete or whatever the deal is, that, there are things you can predict about S curves. This is going to be an S curve. The tail end of that S curve is way out there, but it's going to be an S curve. And the thing is, predicting the exact point when it goes vertical, that's really hard to predict, right? You can say things about the overall shape of it, how high it's going to get, the slope when you're in the middle of it, and that kind of stuff. But small changes in critical things early on shift you 3 months this way or 3 months that way. I wouldn't be surprised to see them, expand the area in Austin a couple of times within the next couple of months, and then add a second city, a couple of months later. Like, I think that's entirely possible. I also wouldn't be surprised if they still have monitors in the car 3 months from now and they still got stuff going on. it's hard to say externally because we don't get a lot of visibility into the metrics. Like, we don't see the data that they're gathering. We don't know what their metrics are, and we don't know what the slope of improvement is. The data we have is the stuff that Elon tells us about this. And people can discount that if they want to, because we do get the Elon time thing. But it's worth pointing out, he's on the money with a lot of predictions. Like, he's slow on some predictions, and he hasn't been slow. Like, he hasn't been slow on the Robotaxi predictions. Like, his predictions about V13 and the Robotaxi rollout, they hit the deadline that he set for them.
So as an investor, and I'm following this, what is the thing I should be looking forward to see whether or not this is going to turn into a real earnings, impacted earnings by the second half of next year, needle mover, as Elon said, or things will be maybe derailed 100%, completely derailed? What is
I would look to see how fast it expands through these. I think once we have a couple of points, once we have a couple of points on the curve of like, how is the Robotaxi expansion going, then you can extrapolate forward. But we have to get past the beginning. We're at 30 cars or whatever in Austin right now, so it's a really small thing. So we're on the flat part before we're just entering the exponential part. And you're not going to be able, at a minimum, you have to get well into the exponential growth of the early phase before you can figure out what the exponent of growth is and make a prediction. I think you can't make it right now, but I don't see good reasons to doubt, essentially what Elon has said about this kind of stuff. Like, there isn't anything I understand technically about this problem, and there's nothing in the data that I've studied that suggests like there's good reason to believe that he can't be right. Like, he could entirely be right. And his track record recently has not been bad.
Wow. Okay.
So yeah, he said mid next summer. That is almost exactly what I would guess.
Needle mover for actual earnings.
Where it shows up on the bottom line, like it's a big enough business that they break it out as a separate number and they give us some history about it, and you can start to see the shape of that curve, right? I don't know, I've been an investor for a really long time. I was an investor back before the internet boom, so I got to go through all of that stuff. So I've seen volatile markets, and it is really hard to say at what point Wall Street gets it, or even retail investors get it, right? And we're in a really weird environment where, the media environment is so polluted with disinformation surrounding this kind of stuff that, in a sense, until really concrete, totally not indisputable numbers start getting put up, it's possible that big investors won't respond to it until it's clear that this is absolutely going to happen, and all the fear mongering and whatnot is just misplaced.
Yeah. So Elon himself referred to a ChatGPT moment when everybody will realize that autonomy actually works. And yet here we have Robotaxi launched last Sunday. They actually had the very first vehicle drive itself. Crickets. Nobody out there, no article written about it. Nobody even realizes this happened. And others will say, there won't be a ChatGPT moment. ChatGPT happened because an app came out and everybody was easily able to download the app and just be blown away how incredibly intelligent this AI is that I'm having a conversation with. That's not going to happen with Robotaxi or Tesla cars. It's really individual, small pockets. Waymo's been around in 7 cities and nobody knows about it. Is there going to be a ChatGPT moment, you think?
I guess there are different ways to interpret that. Like, ChatGPT, one of the fastest growing products ever, fastest to crazy revenue ever. And most people in the world don't use it. Yeah. If you pick some random person off the street and you ask them to tell you what ChatGPT is, 90% chance they won't be able to tell you. Right. So, because we're super early stage on this kind of stuff. And Robotaxis, the big story here, it's fun to play when do I buy my stock options, kind of thing. But it's worth keeping in mind that what's important about this is that it's going to make the world a lot better in a really significant way. And it's going to do that for a billion people, for billions of people. Like, it's going to clean up the air. It's going to let us reclaim our cities from the vast amount of infrastructure we have to devote to cars. It's going to let us all spend less time we're going to waste less time doing this kind of stuff. It'll eliminate road rage. It'll virtually eliminate traffic accidents that kill people, that kill like 1.2 million people a year, most of whom are pedestrians, right? Like almost all that stuff is going to go away. That stuff is definitely on this ramp, and it's not 50 years away. It's not 20 years away. Like we're going to see all of those changes much sooner than that. So to me, like, it's like focusing too much on whether it happens in 3 months or 6 months is very secondary to like appreciating this moment in time that we're in, where the world is going to change and be dramatically better in a few years, a very small number of years at this point.
Wonderful. Thank you so much, James. That was wonderful. You shared a lot of information, confirmed a few things, but most of this I did not know. And I think the audience really appreciate you spending the time with us. Follow James on his X account at James Douma. Thank you very much. And we're going to do a second show here with Dr. Scott Walter talking about Tesla's humanoid robot Optimus. So watch out for that video, which will drop separately. Thanks, everybody. Bye all. I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.